So students, in this video we will see, suppose we have two terms a and b, and we want to insert a term between a and b so that it should be an AP. Then we studied that we could just take an arithmetic mean, a plus b divided by 2, and suppose that is a, okay, capital A. We studied that we could just do that, and we would get capital A is equal to small a plus b whole divided by 2. But what if I want to insert multiple terms in between? What if I want to do that? How would I do that? Now that is not, arithmetic mean is not enough for that. I mean, simple arithmetic mean is not enough for that. So what we can do is, let us, by the way, when we should know that we are trying to make an AP by inserting many terms. Even after inserting many terms in between, what we still want is an AP, right? So what is an AP? The difference between each of these terms is the same, right? Now there are 8 terms now, right? In this example there are 8 terms, and so I can write b is equal to a plus 8 minus 1d, which is our formula we studied, a plus n minus 1 the whole into d. This is the formula that we studied, right? That an any term we can find by this formula, right? We studied that. Now using this formula I can say that b, the last term here, is equal to the first term a plus 8 minus 1. Why 8? Because n minus 1, 8 terms, n is equal to 8, because we studied this is for n terms. Here there are 8 terms, so n is equal to 8. 8 minus 1 into d. Okay, so but what I am interested is in these new terms. So how many terms are there? New terms 6. Small a and small b were already there. The new terms that I introduced was 6. So I'll write this 8 as 6 plus 2. Okay, now I'll just solve it. B is equal to a plus 6 plus 1, that is 6 plus 2 minus 1 is 6 plus 1. So after that I am trying to find the formula for d. So I'll try to put d on one side and everything else on the other side. So doing that, b minus a is equal to 6 plus 1d, then d is equal to b minus a whole divided by 6 plus 1. Now see, so I got the d. So with this d, what all can I do? So see, if I know the value of d, I can find each and every term. I can just add d, this plus d is equal to a1 plus d is equal to a2, and that plus d is equal to a3. So you see that? Do you see that? I just have to add d and I can get every term. So the main issue is that I need to find a formula for d. This is the main thing, and now that is found. But this is only for 6 terms. But what if I had like k terms? I mean, like, how much of a term? How can I generalize it? So to do that, there's no issues. Instead of 6 plus 1, just write k plus 1, because 6 was the new terms. Instead of 6 we are adding k terms, then write k plus 1. That is all, and this is your formula to find d. Okay, now if you find d, then you can find each and every term, right? Now another thing that I want you to notice is k is the number of new terms. So for example, here this is k, that is not k. The number of k's, this is only k1, and this is 2 terms. So k is, n is 3, because n is the total number of terms, and k is in new terms, number of new terms, so it is only 1. Okay, but suppose let But suppose if I had more, I had one more term, then k would be 2, n would be 4, right? Suppose I had more terms, k would be 3, n would be 5, and it goes on. So I can say that n is equal to k plus 2 in all cases, right? In all cases I can say that. You can look at it. In all cases I can say that n is equal to k plus 2. So why I showed you that is, you should realize that these two are two different things. So the total number of all the terms is n, and the number of new terms that we are inserting in between is k. Okay, so and this is our formula to find d. Now in the next video we will see how to do the same thing when we have to insert many terms and we have to make it a geometric progression. So see you in the next video.